So in this video, we will solve some of the problems related to water pressure. So just for a revision, we will revise the formulas for pressure. So pressure is equals to depth into density, and thrust is equals to pressure into area. So this we have already discussed. So these two formulas are very important, which we will be using for further problems. So first is find the thrust on a keel plate 10 meter into 2 meter when the draft of the ship is 5 meter in salt water. So as we know, pressure is equals to depth into density. So depth we know that is 5 meters, that is the draft of the ship, and saltwater density that is 1.025. So it will come out to be 5.125 tons per meter square. So this is the pressure. To find out thrust, so thrust is equals to pressure into area. So pressure is 5.125 and area of a rectangle is 10 into 2, that is length into breadth. So these are the dimensions given of the keel plate. So 10 into 2. So it will come out to be 102.5 tons. So this is the thrust. So now next question. So in this question, a tank has a rectangular bulkhead 20 meters wide and 10 meters high. So we'll draw the rectangular bulkhead first. We'll mark the dimensions. This is 20 meters wide and 10 meters high. I'll label it. So it is 20 meters and this is 10 meters. Find the thrust experienced by the bulkhead when the tank is full of oil of RD 0.9. So density is given, density is 0.9. Now when we fill this tank with RD of oil, RD 0.9, the oil is filled having RD, that is relative density, as 0.9. So when we will fill this, the force is acting the geometrical center. As we know, at what height will be the geometrical center? That will be the 5 meters, because it is a rectangle. So half is 5 meters, height of a rectangle is 10 meters, and half of the height is 5 meters. So always remember, vertical bulkhead, pressure acting on the geometric center. Geometric center. This you need to remember. Density we know 0.9 and depth we also know that is 5 meters. So pressure is equals to depth into density. So depth is depth into density. So depth is 5 meters. So depth is 5 meter and density is 0.9. So it will come out to be 4.5 tons per meter square. That is pressure. Now we need to find out thrust. So to find out thrust, thrust is equals to pressure into area. So we know the area of a rectangle is, now this is 20 meters wide and 10 meters high. So 20 into 10, and pressure we can take from the above equation, that is 4.5, and it will be 20 into 10. So it will come out to be thrust is 900 tons. That is the thrust. So we will move forward to next question now. So next question is, a lock gate is 30 meters wide and 10 meters high. The water inside the lock is 7 meters deep and of RD 1.005, and that outside is 5 meter deep and of RD 1.025. Find the resultant thrust and the direction in which it acts. So for this question, we'll draw one diagram. Suppose this is a lock. Okay. So this is a lock. So the water inside the lock. So inside, first we'll draw inside. So inside the lock is this side. So this you can say inside, and this you can say outside. So the water inside the lock is 7 meters deep. So this height is inside the lock is 7 meters. Okay. And RD is also given. RD is 1.005. RD 1.005. Okay. Now outside. So we'll draw outside. Outside is 5 meters deep. So this is outside. Outside is 5 meters deep. Draw. This is 5 meters and RD is 1.025. So 1.025 means this is seawater, and this is maybe dock water. Okay. And the dimension of the lock gate is also given, that is 30 meters wide and 10 meters high. So we will draw the lock gate also. So rectangular lock gate we will draw, and we will mark it. So this lock gate is 30 meters wide and 10 meters high. Okay, this is lock gate. Now we need to find out that how much is the thrust inside and how much is the thrust outside. So as we know, on vertical bulkhead, the thrust will act at the, sorry, the pressure will act at the geometric center. So how much is the geometric center for inside? That will be, this will be 3.5. And how much is for the outside? That will be 2.5. Okay. So we'll start our calculation now. So we will first, considering water inside. Consider water inside. So inside is how much? This will be pressure is equals to depth into density. So depth inside we know that is 3.5 and density is 1.005. So it will come out to be 3.5175 tons per meter square. So this is the pressure. Pressure inside, you can say. Pressure inside I. Okay. So thrust inside will be equals to pressure into area. So pressure is 3.5175 and area is 30 multiplied by height is 7 meters. So as we can see from the diagram, this height is 7 meters inside. We are considering the inside one right now. Okay. So it will come out to be 738.675 tons. So this is the thrust inside. Now we need to consider the water outside. So now consider water outside. So by considering water outside, pressure is equals to, pressure outside is equals to depth into density. Now outside, as we know, the depth is geometrical center, so depth will be 2.5 and density is 1.025, that is seawater. So it will be 2.5 is the depth and density is 1.025. So it will come out to be 2.5625 tons per meter square. Now we will find out the thrust. Thrust outside. Thrust outside will be equals to pressure into area. So pressure is 2.5625. Area is equals to 30 into how much is the height of water? That is 5 meters. So you can see from the diagram that this is the width of the log gate and the height till which water is filled is 5 meters outside. So outside thrust will be equals to 384.375 tons. So this is thrust outside. But we need to find out resultant thrust. So we can write a resultant thrust will be equals to thrust inside minus thrust outside. So 738.675 minus 384.375, which will give you, which is equals to 354.3 tons. So this is resultant thrust. Okay. But we need to mention the direction also. So this we find out resultant thrust. So as we know, thrust is acting from inside to outside. So it will be thrust is 354.3 tons acting outwards. Okay. So this will be the magnitude and this will be the direction. And we can say as thrust inside is greater than thrust outside, so thrust is acting outwards. Okay, so we have solved the problem. Now we will move forward to next problem. The next problem says a deep tank 10 meters wide and 10 meters deep has a rectangular manhole at its forward end. The longer sides of the manhole are horizontal and its lower edge is 0.7 meters from the bottom of the tank. Find the total pressure experienced by the manhole cover when the tank is full of oil of RD 0.8 to an allege of 1 meter. So as we know from the question, so we need to first draw the diagram always. So we'll draw a deep tank 10 meter wide and 10 meter deep. So we'll draw one deep tank first. Okay. So suppose this is the deep tank and we will label it 10 by 10. 10 meter by 10 meter. Has a rectangular manhole 1.2 meter into 0.6 meter. So we need to draw one rectangular manhole also. Okay, so this is the manhole, which is 1.2 meters into 0.6. So we will make like this. So this length is 1.2 meters and height is 0.6 meters. Okay. The longer sides of the manhole are horizontal and its lower edge is 0.7 meters from the bottom. So this height is 0.7 meters, okay, from the bottom of the tank. Find the total pressure experienced by the manhole cover when the tank is full of oil of RD. So tank is full of oil of RD. So we will draw this is oil of RD 0.8. Okay. So this is filled with oil of RD 0.8 and to an allege of 1 meter. So this allege is 1 meter. So if this allege is 1 meter, you can make out the height till which the liquid is filled is 9 meters. And this we can make out. Okay. So now we need to solve the problem. So we need to find the total pressure experienced by the manhole cover when the tank is full of oil of RD. So we need to find out the pressure acting on the manhole cover. So we need to find out the center of the manhole cover first. So center of the manhole cover is this point. This is point C. Okay, and this point is 0.3 from the bottom of the manhole, and it will be 1 meter from the bottom of the tank. Okay. So as we know, depth of tank is 10 meters. So depth of tank is 10 meter. Then allege is 1 meter. So depth of oil is 9 meters. And this we know. Height of C below the surface. So we need to find out height of C. So height of C above the bottom will be 1 meter from the bottom of the tank. Height of C from bottom of tank is 1 meter. Here we have already mentioned. So depth of C below oil surface. So depth of C below oil surface is from this point till this point. It will be how much? It will be 9 minus 1, 8 meters. So it will be equals to 8 meters. Now pressure at C will be depth into density. So how much depth will take? We'll take 8 meters. 8 into 0.8. Because the oil has RD 0.8, so we will take the density 0.8. So it will come out to be 6.4 tons per meter square. Thrust will be equals to pressure into area. So it will be 6.4 into area is how much? 1.2 into 0.6. The whole manhole cover is submerged, so we'll take the full area of manhole cover. So it will come out to be 4.608 tons. So this will be the thrust on manhole cover. Okay. So this manhole cover will experience the thrust of 4.608. Okay, so we'll move forward to next question now. A collision bulkhead is in the form of a rectangle 10 meter, 13 meter, 13 meter. Find the thrust experienced by it when the salt water is run into the four-peak tank to a sounding of 9 meters. So we need to first draw the collision bulkhead. We will draw one collision bulkhead first. Okay. So this is a triangle. Now we will label it first. So this is 10 meters. This is 13 meters and this is 13 meters. So this is 10 meters. This one is 13 meters and this one is 13 meters. Find the thrust experienced by it when the salt water is run into the four-peak tank to a sounding of 9 meters. So we need to mark. First we'll separate it in two parts. Because we need to use the similar triangle concept in this. Okay, then we need to first verify the height by using the Pythagoras theorem. Okay, so we need to verify this perpendicular. So we will use Pythagoras theorem. So by using Pythagoras theorem, that we know hypotenuse square is equals to perpendicular square plus base square. So here hypotenuse is 13, so 13 square is equals to, this is 5. So 13 square is equals to perpendicular we need to find out and base is 5. So perpendicular square is equals to 13 square minus 5 square. So this will come out to be P is equals to 144. Sorry, P square is equals to 144. So P will be equals to 12. So we know that this height is 12. this thing is 12 meters. I'll keep this outside. So this is 12 meters. And now we know that. Before that, before we proceed, we will label the diagram. So we can say this is triangle MNO. Okay. Now it is filled to a sounding of 9 meters, as we can see from here. So we will mark the sounding, that is 9 meters. So this is 9 meters. So now we know that this height is 9 meters. So M and O we have marked. We will mark this P, Q, this is R, and this is S. So M, N, O, P, Q, R, S. Okay. So we have labeled everything because we are going to use the similar triangle concept. So we need to mark these all. Okay. So now we need to take out. Now we need to take out one triangle outside. So suppose this triangle and the other one we will take. So we have took two triangles. Those are, this is point O, this is RN and SQ. RN, RN and SQ. Okay. So as we know, this OSQ and ORN are similar triangles. So we will use the concept of similar triangles. And we know that this is 12 meters. This we know 12 meter, and this we know 9 meters. This we know this is 5 meters. So we can find out this. And this also we know that is this is 13 meters. Okay, so what all we know we will write. This is 9 meters, this is 12 meters, this is 5 meters, and this is 13 meters. Now as we know that triangle OSQ is similar to triangle ORN. Okay. So OS upon SQ is equals to OR upon RN. Okay. So OS upon SQ is equals to OR upon RN. This is simple similar triangle, and now we will enter the value. We will insert the values. SQ is equals to OS upon OR into RN. OS is 9 meters. OR is 12 meters, and RN is 5 meters. So it will come out to be 3.75 meters. So SQ we found out. SQ is this one. This is 3.75 meters. I will mark in the above diagram also. We found out this is 3.75 meters. Now we need to find out the center point of this triangle. So area of triangle OPQ. We need to find out area of triangle OPQ. This is the one, OPQ. Okay, we need to find out this area. So as we know, area is equals to half into base into height. Area of triangle, simple formula. So area of triangle OPQ. Area is equals to half into base into height. So half into base. Base is how much now? 3.75 into 2. And height is 9 meters. So it will be 3.75 into 9. This will be equals to 33.75 meters square. So this is the area of the triangle. Now area of immersed part of bulkhead is how much? 33.75 meters square. And we can see that this part is immersed, so this area we found out. But we need to find out the center point of this triangle, so that will be here, C. And this height we need to find out. So to find out this height, as we know, SC will be equals to 1 by 3 from base and 2 by 3 from apex. So into 1 by 3 into 9, which will be equals to 3 meters. So this is 3 meters. Now as we know that pressure will act at geometric center, so we will find out the pressure now. So pressure will be equals to depth into density. So depth is from top, from the oil surface, from the water surface, that will be equals to 3 meters into density, that is 1.025, is full of salt water. This we have read in the question. When the salt water is run into the four-peak tank to a sounding of 9 meters. Okay. So 3 into 1.025, it will give you 3.075 tons per meter square. And thrust. Now we need to find out thrust. So thrust is equals to pressure into area. So pressure is 3.075 and area we just now found out 33.75. So it will be equals to 103.781 tons. So this is the thrust. Now we'll move forward to next question. The next question is, a double bottom tank measures 20 into 20 into 1, has its air pipe extends 12 meter above its top. Find the thrust on the tank top when it is pressed up with salt water. So we'll first draw the double bottom tank. That is, will be something like this. This is a double bottom tank, air pipe. Then we will label everything. This is length, this is width, and this is height, and height of air pipe. So we'll write everything. This is 20 into 20 into, this is 1 meter, and this is 12 meters. So total height is how much? This total height from here to here is 13 meters. So pressure, as we know, pressure is equals to depth into density. So it is pressed up with salt water, and we need to find out that how much is the thrust on the tank top. So thrust on the tank top means this one over here. So it will be equals to, this is how much? This is 12 meters. So depth is 12 into density is 1.025. So it will be equals to 12.3 tons per meter square, that is pressure. But we need to find out thrust. So thrust is equals to pressure into area. So pressure is 12.3 and area is 20 into 20, because this is 20 and this is also 20. So it will be 4920 tons. That is the thrust. So now we will proceed to next question. That is, find the thrust experienced by the flat keel plate, that is 10 into 2 meters when the draft is 8 meters in salt water. So this is again a simple problem. We just need to find pressure is equals to depth into density. So depth is how much? Depth is 8 meters into density is 1.025, because it is saying salt water. So it will come out to be, will be equals to 8.2 tons per meter square. Now we need to find out the thrust also. So thrust is equals to pressure into area. Pressure is 8.2 and area will be 10 into 2, flat keel, 10 into 2. It will be equals to 164 tons. So this is the thrust.